Hello, and welcome to part 2 of this lesson about end behavior and domain and range. So we just reviewed how to write intervals down, like some from 5 to 10, or 3 to 16, or we got 9 to infinity, or negative infinity to 6. Those are all intervals that you should be able to write and understand what they mean. But now we're going to dive into what end behavior and domain and range are. Well, let's start with end behavior. So let's say you have a chance to go on this awesome roller coaster. It's an infinite roller coaster. It's going left forever and right forever. And you're going to start here. And you get a nice little car, put you in there. You're like, woohoo, this is going to be awesome. Well, let's say you get to choose. Do you want to go left or right forever? Well, let's say you want to go right forever. Whee! You go down, you come back up, and then the cart just goes up and 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 just keeps going up. All right, well, maybe you don't like that option. Let's see what it would look like to go the other way. The other way, you just go, wheel! You just go down and 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 down. And just kind of goes on for a long time. Maybe you don't like that option. Maybe you don't want either option. Well, too bad. You had to choose. Oh, no. What did I do? I'm just going to push undo. Right. Yeah. So you need to decide, would you want to go left forever or right forever? Well, if you were to go right forever, this function would continue to go up and up and up. If it went left forever, you'd go down and down and down and down and down. And there's a way to write that down, and it's with this fancy thing called limit notation, and it looks like this. Try not to be scared. This is just notation stuff. You'll get used to it. It's fine. So limit notation, the way you read it is the limit of f of x as x approaches positive infinity is c. In this case, you put a number, right? What is it approaching as the x's go to positive infinity? Well, that'd be the right end behavior. If you want to do the left end behavior, it looks like this. The limit of the function f of x as x approaches negative infinity is, and whatever is happening on the left side. That's kind of the notation. That's how you read it. I want to point out that f of x means a y value. And then that means you're saying the y value as the x's do something. What's going on with the function? How high or how low does it go on either side of the function? So if I were to go back to my little roller coaster example, and I want to write my right end behavior, this idea that goes up forever, I'd write the limit of f of x as x approaches positive infinity, and that's to the right, right? The x's keep going up and up and up. Well, this function also goes up and up and up forever. And so you can put equals infinity. Okay. It just keeps getting closer and closer and closer and closer and closer and closer to infinity. It just goes up forever. If I want to write the left side, then I write the limit of f of x as x approaches negative infinity is, well, it keeps going down forever, so the y's also go down to negative infinity. So there we go. We got all these things going on. We got left end behavior, right end behavior, and that's how you write them down. You just say, well, what's going on the left side? Sorry, what's going on the right side? What's going on the left side? And you write it down. So take a moment. I would like for you to write down, we're going to use 4 as an example. Go ahead and write down the end behavior for this function as you go right forever and as you go left to, well, this is just to 2. Yeah, go ahead and see if you can fill in what's missing on your end behavior here. Did you get it done? Did you realize that on the right side here, it continues to go up and up and up and up, and so you're going to put positive infinity. This one here, what's happening on the left side as x approaches 2, which is here, well, it's getting closer and closer and closer to this y value here of 1. So you put 1. That's it. It's approaching a height of 1, so you put 1. Ta-da! End behavior. Easy peasy, right? Easy peasy, lemony squeezy. I'm sure. Okay. So that's one property to be able to write down. The other one is, well, the other pair is domain and range. Domain and range stand for the x's and the y's, or like what's going on horizontally and what's going on vertically with your functions. And here's some examples. If your x's go left and right forever, that'd be all real numbers. That'd be negative infinity to positive infinity. So maybe your y's don't, yeah, for some reason this is horribly wrong. For some reason on your y's, it doesn't go above 8. Like, it gets really, really close to 8, keeps getting closer and closer to 8, but everything's below 8. Your interval would look something like this for your domain. Or if you want numbers that are at least 2, maybe on your y's, the lowest point is negative 2, and it goes up from there. You put negative 2, comma infinity. So that's what those things are. Look at. We're going to do a few examples, just writing down domain and range so you can get used to them. Let's look at 2 here. We got g of x. Here's the function. It's already graphed for you. So we're just going to look at this. Domain, again, is x's. And so you need to think, what's going on horizontally? How far left does the function go, and how far right? Well, this function is going to continue to go left and left forever, so I'm going to put negative infinity. And then on the right side, it's also going right forever and ever and ever, so I'm going to put positive infinity. Ta-da! Domain, done. Question marks, done. All right, the range, well, you think about, well, how far down does this function go? And then how far up does this function go? Well, when you're trying to figure this out, it doesn't matter what side you're looking at, just whatever is the lowest side anywhere, how low does that go? And then comma, doesn't matter which side or where along your function, what is the highest it goes for the right part of your range here? Again, this is y's. Well, this function, as you can see over here and here, is going down forever, so the lowest y value it's approaching is negative infinity. But it doesn't go up forever. It does have a maximum y value, and it's here. And that maximum y value is 3. So on your range, you're going to put 3. And since it actually hits 3, that 3 is the highest y value, you're going to put a square bracket instead of an open bracket. If instead your function was curving towards it, something like this, like an exponential, this is kind of what exponentials look like, that would be getting closer and closer and closer and closer, but it doesn't actually reach 3. In that case, you'd put an open bracket on 3. That's not the case here. It does actually hit 3, and so you put a closed bracket on 3. So ta-da, there's your domain and range. So what I'd like for you to do is go to number 4 and see if you can write down the domain and the range for this square root function. Pause the video, try it out. All right, for your domain, since this function, the left end of it is just at 2, the domain actually starts at 2. And then this function goes right forever, and so you're going to put infinity there. Infinity is always open, and the lowest x value is 2, so you're going to have a square bracket on 2 and actually hit that x value. On the range, again, you're thinking vertically, what's the lowest it goes? Well, this point here is the lowest point, and the lowest y value is 1, so I'm going to put 1. And then comma, this one is going up forever, so my y values also go to infinity. 1 is the lowest point, so I'm going to have a square bracket on the 1. It's the lowest y value. So there you go. That's what's going on. So you're going to look at your different functions, write down your domain and range, your end behaviors. Realize that if you have something like this, it goes up, down, and up. When you're writing down your range, it doesn't matter that this maxes out. Over here, it keeps going higher and higher. And so your range is going to be from negative infinity to positive infinity. Even though in the middle there's like a max here and a minimum, it does go lower over here. So you just have to think, what's the highest and lowest it goes anywhere on my function, not just in certain sections. So there's that. And then on the final section here, it gives you some properties, and you need to draw your own function that has those properties. So what I like to do is just maybe start with my end behavior and think, okay, so both of these say on the right side it goes to infinity, left side it goes to infinity. That means it's going up on both sides. So I come down here and make a little note. Go up, go up. So left side and right side is going up. Perfect. And then I look at my next part. Okay, domain, negative infinity, positive infinity. That just means it's going left and right forever. Next part is range is -1 to infinity. So let's know this is the lowest. It goes, that's the lowest y value, and this is the highest. It goes, and we already know it's going up forever because of our end behaviors. So really, I just need a function that the lowest y value is -1, which is down here. And so, you can put a dot here, just anywhere. And it just goes up on either side. Ta-da! Function done. Or if you wanted to, you could have multiple things going on in the middle. We don't have a whole lot of other directions. So it could be doing this and this and this. It just has to go up on either end. So you can kind of do whatever you want. It just has to meet those requirements listed. So there you go. That's your assignment. Give it a shot. Go in and practice. Get used to writing down your end behaviors, your domains, and your range. And good luck.